Missing mean or standard deviation in normal distribution. So this is the final type of normal distribution problem. As I mentioned earlier, there's three types of normal distribution problems. One where they want you to find the probability. So it's usually something like, oh, x is greater than k, or x is between 1 and 5. So what you do is normal CDF. Right, normal CDF, E99 to whatever, or 3 to E99, all that good stuff, right? That's the basic one. X greater than 3, x is less than 2, or x is between like 1 and 0. Something to that effect. That's the straightforward normal CDF putting your calculator done. The second one is where you're given the probability. They want you to find k. So this is where you're going backwards, right? There'll be something like x is less than k equals 0.3. Right, probably x less than k is equal to 0.3. And now we have to do invert normal. Remember, it has to be the left-hand side to work. But that's the idea, right? So we've talked about two so far. One's the most straightforward. Oh, you're between these two values. Greater than this one value, less than this one value. Let's do normal CDF, right? We always use CDF, or we always use CDF or invert normal, never PDF. Second one, they give you the probability, like, oh, the probability of this happening is 15%, 3%, something to that effect, right? And they want you to find so you have to use invert normal to find it. This final one, the one we talk about in this video here, is what if this sigma standard deviation or mean is missing? If one of those two are missing, then the way we do it is we have to do invert normal again, but first we got to normalize. That's when we use this formula extensively. So we do that, and then we do invert normal. We'll actually go over it. But and I'll talk about more why we have to use that form. But that's what we're gonna do in this video. We're gonna talk about the third way, the final way. Probably for most people, the most difficult one. But it really is, if you're missing something, if you're missing a standard deviation or a mean, you just gotta use the invert normal, and we'll talk about in detail why that is. And that's this one. So as we talked about earlier, right? Anytime you have a quartile, you must convert. So for some questions, we must convert to z-scores, right? Z-scores are just z just means normal, the standard normal. Right, so that's where you have the 0, 1. Right, so sometimes you have to convert to that. And that's anytime we're missing one of these things. So like I said earlier, if you're missing sigma, or you're missing mu, or missing both sometimes, you must use this formula. Why? Because this formula gives us, we could find z easily. So what we do is we're going to use that. We're going to have z, right? We'll have what x is. We'll have what one of these is. We won't have the other. And what we do is we could find z easily, because z has relates to our x value, because this has a mean and standard deviation. It has 0 and 1. So that's why we use it. Because the fact that when we use z, we have a mean and we have a standard deviation, which is 0, 1. So we use so the way it works is this: if you're missing one of those, step 1 is you got to find z. Right, using the formula to find z, and then once you do that, you can set up the equation and solve. And that's how we're going to solve these. So anytime you're missing either mu or phi, that's going to be our process. Is we're going to find z, we're going to find z like we normally do, invert normal. I should write that down, right? How do you find z? Invert normal with 0, 1, right? That's special for z. That's why we do it, right? I'm missing something. I can use z because z has standard deviation mean, right? If I don't have it, how am I going to use it? But z has it. So we find z first. How do you find z? Invert normal with our x value and 0, 1. And once we do that, we get our z-score. And once we have a z-score, we can set up this equation and solve. Because we're going to have z, we'll have x, and we'll have one of the two. It's just an algebra problem. So that's how we're going to solve these, right? Anytime you're missing mean or q, you gotta use the standard normal equation. The only time I ever use it, really. And then you gotta find z first. Invert normal 0, 1, because z is special. Remember, z is 0, 1. And once you do that, you get a step equation and solve. So let's do a problem. An adult scallop population is known to be normally distributed with a standard deviation of 5.9. So that's our standard deviation. If 15% of scallops weigh less than 0.583, find the mean of the weight. So notice how we're missing the mean. We have to find the mean. So if I see myself missing anything, first thing I do, put down that formula. It's like, oh, missing something, I have to use this formula. That's just the way it is, right? If you're missing something, you can use this formula. And we have a lot of stuff already. 50% of scallops are less than 58.3. That value there is my x, 58.3, 58.2. I have my standard deviation, 5.9. I don't have this. I'm looking for that. That's what's missing. And remember what I said like a little second ago? The very first thing you do when you have this is you gotta find z. Right? So once I find z, I can set up that equation and solve. So you gotta find z. That says fine. Find z. Now, how does it work? Well, we gotta convert this first. So there's some x. It says, 50% of scallops are less than, so x is less than 58.2. The probability you're less than 58.2 is 15%. Right? That's the way it works, right? You're less than 58.2, it's 15%. So we could draw that. Right? 58.2 is over here somewhere. Oh, look, I know. Okay, sorry. Less than is 15%, so this is 15%. This is 58.2. So what I'm going to do with this value here is I'm going to do invert normal. Because that's how I'm going to find my z. I want to find my z. And z is invert normal with my x value and 0, 1. Right? That part never changes. 0, 1. Right? That part never changes. Invert normal, 0, 1. That's what the standard normal is, 0, 1. In this case, it is less than, so I lucked out, and I put 15. So my area is 15 here. So I lucked out. Plug that into our calculator, right? It's been a little while, so I'll show you. Right, so we're going to invert normal, we'll do second distribution. Invert normal. 0.15. Now again, it is a standard normal, so I automatically know it's going to be 0, 1. Anytime they say z or standard normal, you have to know that. And I get negative point, hey, how it goes away, 0.4. Negative 1.04. That's my z-score, right? Not done yet. I just got the z-score. Plug that baby back in, and now we have an equation. Negative 1.04 equals 58.2 minus mu over 5.9. Right, now it's just an algebra problem. Multiply both sides by 5.9. And you get some number here. Equals 58.2 minus m. Right, now it's this algebra. Subtract 58.2 from both numbers. Multiply by negative 1 or whatever you're going to do. Just do some algebra and you're going to get m equals. And I get 64.3. So that's the average weight of the population of scallops, 64.3. Where the low end, right, 50% weigh less than 58.2. So low end is 58.2, median is about 64.3. So that's how you do it if you're missing something. But we gotta do another example to make sure we got this. The weekly income of a bakery normally should the mean of this, so this time they give you the mean. Right, so that's a monthly normal. The weekly income of a baker, 61. Whoa, that's way more than I make. I changed professions. Who am I kidding? I can't bake. Anyway, so if 85% of the time the weekly income exceeds 6,000, was a standard deviation, right? So same idea. That's my. I'm looking for my standard deviation this time. 85% of the workers exceeds 6,000, so that's my x. That's kind of my k. Right. So again, notice you're missing something. Very first thing I do is, oh, I'm missing something. I use my formula: x minus mu over sigma. Again, that is in your formula sheet, so you guys use it. X is 6,000. The mean is 6,100. I don't have sigma yet, And all I need to do is find my z. Remember, there's a way to find z. It's called the invert normal. That's how you find it. It's the very first step. Invert normal. Let's see what we have here. The standard 0, 1. Right? So I always like to draw it. 85% of the time the weekend income exceeds 6,000. So if we're drawing this, notice that it exceeds. That's like from the top. Right? Bigger than 6,000. Exceeds 6,000. Greater than. Right? So it's on the top. But it's 85%. So here's 50%. I could go way past that to like 85%. Right? So I get that. Now notice if we're doing invert normal, remember invert normal because I'm trying to find the z-score. If I can find the z-score, I can put it here and I can solve this whole problem. Right? But when you do invert normal, it has to be the left-hand side. So if that's 0.85, I do 1 minus 0.85 or 0.15. And that's what I put in the model. So it's going to be invert normal, 0.15, 0, 1. And that's going to get me negative 1.04. Right? So that's what I get for my z-score. So now, once I have my z-score, you can plug it back in. You get negative 1.04 equals 6,000 minus 6,100 over phi. Right? I can do a little math. Oh, yeah, be impressed. I can subtract 6,100 from 6,000. Right? And then now you just solve it. I would multiply both sides by sigma. It's like a jazz symbol or whatever. So you get negative 1.09 sigma equals negative 100. Divide by that. And I get that equals, and I get about 95.2. Now remember, this is standard deviation, so it makes sense to be low. With huge numbers, so it makes sense it's kind of high. But that's the idea, right? Again, keep in mind that if you're missing one thing, how do you do it? You gotta use it. You gotta normalize it. Once you do that, invert normal, the x value they gave you, you gotta kind of draw it, figure it out, like I did here, figure out probability. So you could get your z value, and then from there, just cross multiply, just basic algebra. Now let's go over an example where we're missing both mean and standard deviation. So right here, we're missing both of them. Right, so let's look at this problem. Find the mean and standard deviation of a normally distributed random variable x if probability of being less than 20 is 0.1 and probability of being greater than 29 is 0.15. So remember, again, notice already from the start, you don't have this, and this time we don't have this. So we don't have both. So yeah, we're going to have to use the normalization formula that we talked about. X minus the average over the standard deviation. Right, so that's in our formula sheet. And that's what we use anytime we're missing any one of these, we have to use that formula. So the difference this time is that we're going to use it twice. We're going to use it once we're going to use it once with this given data here. Alright, so we're going to use it once with this. And then we're going to use it with this. And then so we're going to have two equations, and we have two unknowns. So we just got to use some basic algebra too. So that's like the whole plan, is to use this formula with the given information, both of them, to come up with two different equations. One for this one for that one. And then once you have two equations, we can solve it by elimination or substitution. So let's get at it. This is the first one. So remember, the way this works is, look what they're telling us. They're saying that if you're less than 20, you're at 0.1. So let me draw my little thing here. They're saying this is 0.1 if this is 20. Right, so I want to fill out this formula sheet here. I have x is 20. I don't have this. I need to find my z. And remember, the way you find z is always the same way. It's invert normal. It's terrible. Less than, you can do when it's less than, we have less than, so we're good, 0.1. Now remember, we're trying to find z here. Z is very specific. Z is 0.0, is the standard normal with 0 and 1. Mean is 0, standard deviation is 1. So it's 0.1, 0, 1. Put that into your calculator. Right, again, z is very specific. Right, anytime you see z, you're talking about the standard normal, so your mean 0 and your standard deviation is 1. Hey, it's already set up. So 0.1, blah, 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 enter, paste. Let's round that to 3 sig figs, negative 1.28. So z equals negative 1.28. So now if we look at my formula, I have negative 1.28 equals 20 minus mu over that. Right? So that's one formula. Let's make it a little prettier. Let's multiply both sides by the standard deviation down here, so I could get multiply this by this and this. Negative 1.28 equals 20. Oops, 28. There we go. Sigma minus 20 minus mu. So that's one formula. Now we got to do something to this other side. Right over here, now I got to use this data right here. And the way this works, let's draw it. 15% now greater than or greater than is the right hand side. So this is 0.15. That makes this 29. Right? And again, I want to fill out this formula this time, where this will be 29. I don't have this or this, but I do want to find my z. And we always find z the exact same way. Z equals the invert normal. Right, now here's the problem with this one. Remember what we talked about? When you do invert normal, it has to be less than. So I can't use this 0.15 on the right hand side. It has to be the left hand side. Well, if that's 0.15, you do 1 minus, because the whole thing is 1. 0.15, get 0.85. Right, the whole probability is 1, like always. If that's 15%, this will be 85%. So that's what I'm plugging here. 0.85, 0, 1. Put into my calculator, same way. Put it into my calculator, I got 1.04 if I round it to 3 sig figs. So that's my z. So again, using the formula, let's plug it in. All right, using this formula right here, I get 1.04 equals. Before I do that, take a note that our z here was a positive because it's on the right hand side, right? 29 right here is on the right hand side, bigger than 0, so positive. Our z on this one was negative, whatever it is, because on the left hand side. Makes sense, right? Z is a standard normal. Our mean is 0. Anything above it's positive, anything below it's negative. So all our stuff here makes sense. Anyway, back to the show. This is a 29 now. X is 29, right? That's what we're doing this time. Minus mu over phi. It's like before. Let's make it a little. I'm gonna make it a little nicer. Let's multiply both sides by standard deviation. So I'm gonna get 1.04 sigma equals 29 minus mu. So, right down to that step. Now we have two equations, two unknowns. Now it's just algebra 2. Let me run them together, right? I got 1.04 sigma equals 29 minus mu over negative 1.28 sigma equals 20 minus mu. Right, so we can solve this any way we want. You can do substitution, get mu by itself, plug it in. You can do my favorite, elimination. I think that's what I'm going to do here. Let's multiply the bottom by, I want these to cancel out. Multiply the bottom by negative 1. So I'm going to get positive 1.28 phi equals negative 20 plus mu. Right? And if I add these up, these cancel. And I get 9 equals, is that 2.32 sigma? Divide by, that's a double equal sign, it's terrible. Right? Now divide everything by 2.32 sigma. Just doing some algebra here. And I get sigma equals about 3.88. That's sigma. Now, again, all I did was algebra. I got my two equations, plug them here. I decided to do elimination, so multiply the bottom row by negative 1. To save space, I just wrote it right here instead of rewriting it. I multiply negative 1 by all of these. I got positive 1.28, negative 20, positive mu. The mu's canceled out. 29 minus 20 is 9. And 1.104 plus 1.28 is 2.38 divided by 2.32. Got my answer. Now, almost done. I still got to find sigma. But again, once you get one of them, mu. Once you get one of them, you're pretty much done. All you got to do is plug it back in. Doesn't matter which we plug it into. I think that one probably a little easier. Negative 1.28 sigma, which now I know is 3.88, equals 20 minus mu. Multiply those together, and you're going to get negative 4.9664. I want you to notice I didn't round to 3 sig figs yet. You only want to do that in your answer, right? So like I got my z answer. I didn't like get my z. Actually, last time they would want you to leave it. Not until you get your answer, they want you to round it to 3 sig figs. So only when you get the answer. And you get that. Move some stuff around. Minus 20 equals negative mu. And you get negative 24.9664 equals negative mu divided by negative 1. Now I can round 3 sig figs, which, give me a second, would be 25.0, right? Because that's my third sig fig, but you round it up. So my average is 25, and my standard deviation is 3.88. And that's how I do one when they're both missing, right? That's a lot of work. So let's do it one more time, make sure we have that. So last problem for stats. It's a banded problem here. Last one we're going to do for stats. So it's on to bigger and better things. Circuit metal tokens are used to operate washing machines and laundry mats. The diameters of the tokens are normally shielded with only tokens between 1.94 and 2.06 will operate the machine. That's actually kind of how it works. Find the mean and standard deviation of distribution that given that 2% of tokens are too small, 3% too large. Right, so again, notice what they want us to find. Standard deviation and the mean. And look what they tell us. Right, 2% are too small. It's on this side. They're saying, hey, that's too small. 0.02, too small. And over here we have the threshold for it, 1.94. Says 1.94. And then for that one, where it's too large, same idea. Right, 3% are too large, so 0.03, and we have the threshold that's 2.06. Right, anytime like last time, anytime we were missing the mean or standard deviation, anytime one of those are missing, you have to use the normalization formula. And IB didn't even give you credits for writing it down. Like, oh, they know how to use it? That you're supposed to use it? That's a point. Right, so you know that looks kind of disgusting, but use that formula if you could read it. Here's a better one, because I can't write. Hey, that one's decent. So we're gonna use that formula, right? Like anytime we're missing some mean or standard deviation, that's when we gotta go to, right? For normal, by the way, not any other stuff. It's only for normal. So that's the form we're gonna use. Again, this is the more straightforward one. We have everything we need. We have like, okay, z equals x 1.94 minus mu over sigma. I gotta find what z is. Well, z is always the same thing, right? Z is special. It means invert normal. So invert normal with the standard, which is 0.01. So 0.0201. Get that in my calculator. Negative 2.05. So I goes over here. And again, I'm trying to go a little faster this time. Multiply both sides with standard deviation just because it makes it a little bit cleaner. It goes 1. I get this for my formula. Always forget that. Minus mu. Right? So that's one formula. Again, same thing I did before. I had this. It's on the left hand side, so it's good. Right? I'm missing something, so I use the standard normal formula. Plug 1.9 in, 1.94 in for x. Had to find my z. So how do I do that? You always find the z the exact same way. Invert normal has to be the left hand side, 0.02. The fact that z means it's 0.1. Plug into your calculator, you get this. I made it a little bit prettier by multiplying both sides of standard deviation, but there you go. Let's do the same thing on this side real quick. I'm gonna try to go this one faster. All right. So same idea. I want to use z. And this time I'm using 2.06 for my x minus mu over standard deviation. You got to find z. Now remember, z is the invert normal. But in this problem, I have the right hand side. You have to have the left hand side for invert normal. It's a little thing about that. So 0.97, right? 1 minus 0.03. 0.9701. Again, it's 0.1 because we're doing z, and z is always 0.1. So we put that into my calculator. You put that in, you get about 1.88. So it goes here. Again, I'm trying to go a little faster than normal. And again, just to make it a little cleaner, multiply both sides by standard deviation. I get 1.88 equals 2.06 mu. Right? So there's my two equations. And just like last time, right? I'm going to solve this. Let's do a little algebra, right? Let me put this one right here. I would solve it by probably multiplying the top by -1 because I want these to cancel out. So be multiplied by -1, 2.05 equals -1.94 plus mu. If you add them up, these are going to cancel. And these two, you're going to get 0.12. Over here, 2.05 sigma plus 1.88 gives me about 3.93. Divide by 3.93, right, just to get that by itself. And I'm going to get standard deviation is about 0.031 if I round to 3 sig figs. It was 0.03053 something. So that's my standard deviation. Again, once you get that, you want to find the mean. So I would go back to any one of the two formulas we found. So let's go over here. That one's kind of messy right now. Let's use this one. So I get 1.88 times 0.031 equals 2.06 minus mu. Right, just do some math. Using equal 2.06 minus 1.88, 0.031, and that's going to get me 2.00172, or just 3 sig figs, 2.00. So that's my mean, that's my standard deviation, right? Again, anytime you're missing one or the other, you have to use the normal formula to try to find it. In this case, we're missing both, so you have to do it twice. Once you do it twice, you try to get you get two variables with two unknowns, and once you do that, you just do some algebra, some elimination or substitution. You get your answers. Now the last question here, I'm gonna get to letter B. Find probability that at most one token at a randomly selected sample of 20 would not operate the machine. So a couple things, right? Notice the wording. Find probability that at most one, at most, from a sample of 20, right? You already know what it's going to be. It's a binomial question, right? At most one means x is, right? I want to have most one cookie. X is less than or equal to 1. So it's actually pretty simple. I don't have to change anything. I just got to figure out what the probability is, right? That will not operate the machine. So and that's a little tricky, right? Will not operate the machine. So I'm trying to find a probability. Now think about this logically. Which ones don't operate the machine? You got 2% here, 3% there. So it's those two. It's just 5%. The probability is 0.05. Actually, it has nothing to do with this stuff right here, right? All we need is, I didn't even need part A really, besides the fact to read the question, right? That won't operate a machine. We got 5 things that don't operate a machine. 2 of them are too small, 5 or 3 of them are too large, so 5%. So my probability is going to be 0.05. My number is 20. Right? That's all I need to plug into my calculator. Again, I didn't even need all the answer from me. That didn't help me at all. Right? It's just understanding what the question was. So I get my calculator out real quick. We're doing a distribution at most 1, so CDF, because right, PDF is only when it's equal to. That's for binomial. We never use it for normal. So it's 20. Probability is 0.05. And I'm on at most 1. Look, it was at most. That makes it a lot easier. And I get about 70.736% chance. And that's the way you do this problem. And we're done. Stats. It's here.